Good morning. What I'm going to discuss now are scatter plots, and I'm first going to run through the various kinds of scatter plots that you could have. Firstly, a scatter plot is designed to see or test if there's a link between your two variables. So, if we plot the one variable against the other, and if we find that the points we get are strongly clustered in an increasing line, we would call this a positive correlation. We would very easily be able to put a line of best fit through these points. In the second example, the points are not as strongly clustered, but I still see an increasing line through here. If I wanted to draw a line of best fit, I could draw that. And the points are not as close to that line, but it is a positive correlation because it's increasing. But we could give another word. We could say this is a weak positive correlation. In the third example, I can distinctly see that these points have a downward trend, a decreasing line. However, the points are not closely clustered to a line, but I can still see a line of best fit maybe running through there. So I would call this weak negative correlation. In the last example, the points are closer together, and if I draw a line of best fit, these points are closer to this line, and I would call that strong negative correlation. So the negative refers to the decreasing part, the positive refers to the fact that it's increasing, and then the second adjective, weak or strong, is an indication of how close these points are to your line of best fit. A line of best fit is drawn. You try to draw it through the middle of the data. You would ignore any outliers. An outlier might be a point that is very different from the other points, and you could ignore those. And you would try to pass through as many of the points as possible and have as many points above as below. So if I look critically at this line of best fit, it was a very poor line of best fit. It should have been slightly higher at the end. This one is not too bad, because there are more or less an even number of points on both sides of that line of best fit. Let's go to the last example. If we plot variable 1 against variable 2, we might find that we can see absolutely no pattern with these points, and then we'd say there is no correlation whatsoever between the variables. I'm just going to clean the board now and quickly give you an example. So the first one we'll look at is seeing if there is a link between temperature and the sales of air conditioners. Sales of air conditioners. Now, this is such an obvious one. You could probably already think that as temperature increases, let's go to 20, 30, 40, well, let's go, we'll start at 5, 10, 15, 20, 25, 30, 35, 40. Okay, so we probably start to see very few air conditioners bought at these temperatures, but here we might see a very strong number of air conditioners bought as the temperatures reach the 40 degrees. And so what would you call this then? So if we draw a line of best fit, it might be something like that. And I would call this strong positive correlation. Right. Let's have a quick look now at the sales of heaters and temperature. So with temperatures as low as 5 degrees, I would expect there to be pretty good sales of heaters. We're on heaters now. sale of heaters. So at low temperatures, we're going to find a lot of heaters bought, and as the temperatures increase, there will be very few heaters bought. So we do see a line here, and that would be then strong negative correlation between temperature. So there definitely is a correlation. So when we say there's a negative correlation, that does not mean there's no correlation. We are saying there is a correlation, but as temperature increases, sales of heaters comes down. And then the last example would be, say, temperature and the sales of vacuum cleaners. And as you can imagine, there would be no correlation between temperature and the sales of vacuum cleaners. No correlation. You would not expect that to have any correlation there. Thank you.